This video will show how to create the following two small R programs. First, creating a new R file in an empty directory, implementing it with a trivial program, printing the classical phrase "Hello World" to the screen. Then the Hello World program will be replaced with another program, which receives input argument from the command line and also receives keyboard input from the user. This video is part of at least one playlist showing how to do the above with different programming languages. There should be a link to that playlist in the description below. Prerequisites. You, the viewer of this video, are assumed to have some skills in at least some programming language. I will not explain basic concepts such as what is a variable or what is an array or what is a for loop. Even if you have never written source code with R, you are assumed to be able to understand, for example, what this R code below does. In this video, I am using Windows 10. I start by showing which version of R and RScript I have installed. If you type R, you start the interactive R console, where you can write R code that executes directly when you're writing a line with R code. If you want to execute R code from a file from inside the R console, you can use the function source with the file name as an argument. RScript is another way to execute R code from a source code file directly from the operating system's command prompt without starting the R console. You can use RScript by typing RScript and then the name of the file with R code. An older alternative to RScript is to type rcmd batch and then the file name, but then any output is not written to the screen, even if you call functions such as print or cat, because you want to print output to the screen. In this video, I will not use rcmd batch. I will instead mainly use RScript to execute code from a source code file that I edit in Visual Studio Code. But at the end of the video, about the last 2-3 minutes, I will be using the interactive R console. The Windows command dir shows that the current directory is empty. In other words, that I am starting from an empty directory. Then I start Visual Studio Code by typing code and a dot, which is the path to the current directory. When Visual Studio Code has started, I create a new script file named arguments_inputs.r in the new directory. Then I implement the initial trivial Hello World script by calling the function cat to print Hello World on the screen. Then I execute the script by typing RScript and then the name of the script file. When the script is executed, the output, Hello World, is displayed on the screen, just as expected. Now I will replace the initial trivial Hello World implementation with the program that will receive and print argument from the command line. The program will also ask the user to enter a name and will then print to the screen what the user typed. For this purpose, I have prepared some pseudocode that I will paste into the program, but within comments, since of course it would not be possible to execute. Then I will modify the code by changing it to R code that can be executed. Now I am showing how the program arguments will be provided to the program when it is executed. The arguments will be added after RScript and the file name, and then a space between each argument. So here I am showing 3 arguments to the program. Any program arguments are available from the function command_args, which returns a vector that I receive into a variable that I give the name args. I am iterating that vector with a for loop, and I choose arg as the name of the element iterated. Inside the for loop, the iterated program argument is printed to the screen by calling the function cat. \n is used to create a line break each time the function cat is called at each iteration of the loop. Then I execute the script in a similar way as before with rscript, and then the name of the script file, but now also with 3 program arguments, with a space as a separator between each program argument. When the program is executed with 3 arguments, it does not work quite as expected. The first 5 so-called program arguments contain something else, and the actual program arguments begin from the 6th element in the vector returned by the function command_args. Therefore, I will now change the source code so that the loop will instead iterate over the vector index from index 6 until the upper limit of the vector, which you can get by calling the function length with the vector variable args as an argument. Inside the loop, I change to use args and the index variable I within square brackets. I can also mention that the vector index starts with 1 to the first element and not 0 as in many other programming languages. When I then execute again, it now works exactly as expected. Now only the 3 actual program arguments are printed on the screen. Note that the first 5 elements that were previously printed on the screen are no longer printed. But this was actually not a good way to solve the problem. For example, it is not obvious that the actual program arguments will always start from the 6th element. The future version of R might add additional arguments. Fortunately, there is actually a better way. Now I return to using the previous loop where all the elements in a vector are iterated. Then I add an argument to the function command_args named trailing only, and if you set it to true, then only the user's argument is returned. When the script is now executed again, you can see that it works as it should. You can also delete the argument name trailing only and only type true. Now I will implement the second part of the program, receiving input from the keyboard while the program is being executed. The question, "What is your name?" is printed on the screen with the function cat. A variable name is used for storing the input from the keyboard returned from the function readlines, which is called with 2 arguments, stdin and a number 1, which specifies the maximum number of lines to read. stdin stands for standard input, which usually means the keyboard. The function cat is then used to print the content of the variable name to the screen after the prefix hello. When I execute the program, it works as expected. Regarding reading from the keyboard, I have now used the function readlines with a big L and an S at the end. An alternative, if you use the interactive rconsole, is to use the readline function with a small L and without an S at the end. That function receives an argument that is the string to be displayed before the input prompt. Therefore, you do not need to first print the text on the screen with a call to the function cat. According to the documentation, the function readline is intended for being used within interactive sessions. I will now show what happens when I use the function readline from a script executed with rscript. As we can see when it is executed, the function automatically returns an empty string without me even getting the chance to type anything at an input prompt. Since the function readline does not work properly when executing with rscript, I will change the source code so that the function readline is only used when the function interactive returns true, and otherwise the function readlines will be used, which is the function I have used earlier in this video when executing with rscript. First, I put the message string "What is your name?" into a variable msg to avoid duplication in the if and else statements that I will soon implement. Then I call the function readline only if interactive returns true, and otherwise the function readlines is called instead. I also add two printings to the screen by using the function cat to show whether the execution is considered interactive or not. These two calls of the function cat can be considered as debug printings. When I then execute the source code with RScript, you can see that it is not executed as interactive, and it works as before since the function readlines is then used. Now I start the interactive R console by typing R. Then I call the function source with the name of the file as an argument to execute the code in the file. As you can see, the code now executed as interactive, and therefore the function readline was called. The input prompt is now displayed where it should be, at the end of the same line that shows the text "What is your name?" and I also get the opportunity to enter a name. But when the line "Hello" and the name has been printed on the line below, then the R console input prompt continues to appear on that same line and then overwrites the first two characters so that only LLO is displayed instead of hello. This problem can be fixed by typing an additional line break at the end with the function cat after hello and the name have been printed. So I add \n after the name. When I then use the file again by calling the function source, it works as it should. Now all of the line is displayed with the hello text, and then the R console input prompt is displayed on a new line. Finally, a few words about how to provide program arguments to a file that is executed through the function source from within the R console. Actually, there does not seem to be any really good way to do it. But one possibility is that inside a session in the R console, you can redefine the function command arg so that you specify the arguments. I found this solution on a Stack Overflow page, where the question was about calling the function source from within another script file. But it is also possible to redefine the function directly in the interactive R console session, which I will show. Now I copy the function from the Stack Overflow page. Then I paste it into my interactive R console, but then change the function so that it returns a vector with the 3 arguments I have used previously in this video. When I then execute again by calling the function source, you can see that the script can access the arguments when command args is called.